Okay, so in this video we're going to have a look at the 2024 Higher Level Maths Leaving Cert Paper 1, and this is question 2. So in this question is going to be a complex number question. We have I squared is equal to minus 1. Find the two solutions of the following equation in Z, where Z is a complex number. Give each answer in the form A plus BI, where A and B are real. So this is our quadratic here. We have Z squared plus 12z plus 261 is equal to 0. So really what we've got to do here is use the quadratic formula, the minus b formula. So let's just write down a is equal to 1, b is equal to plus 12, and c is equal to plus 261. So really it's just a case of plugging these values into our quadratic formula. So our z is going to be equal to minus b, so that's going to be minus 12 plus or minus the square root of b squared, so that's 12 squared, minus 4 times a, which is 1, and c, which is 261. That's all divided by twice a. So let's just simplify this a little bit. We've got minus 12 here, we've got plus or minus, we're going to have something there, and we've got 2 times 1, 2. So 12 squared is 144, and then we've got to subtract because it's minus times plus is going to be minus, so 4 times 261. When you do all of that, you'll end up with minus 900. It's just calculator work at that stage. Okay, so we can see we have a negative value underneath the square root, so we're going to end up with a complex root here, or complex answers. So we've got minus 12 plus or minus, really here we've got, let's see, the square root of 900 times minus 1. So I'll do this in stages. This is 12 plus or minus the square root of 900 times the square root of minus 1, all divided by 2. And I've kind of run out of room here, so I will come up here. So we've got, let's see, we've got minus 12, we've got our z here is going to be equal to minus 12 plus or minus the square root of 900 is 30. So we've got 30, and then the square root of minus 1 is I. You've got to divide that by 2. So what you've got to do here is divide the 2 in here, and you've got to divide the 2 in here as well. So you've got minus 12 divided by 2 is minus 6. We'll do the plus version first. 2 into 30 is 15, I. And z is also going to be equal to minus 6 minus 15i. So they're my two answers for part A. And maybe we'll call these Z1 and Z2. So they're my two answers there. Okay, so let's move on to the second part then, part B. It says, use de Moivre's theorem to write 1 minus root 3i all to the power of 9 in the form a plus bi, where a and b are elements of OR. Okay, so the first thing I'm going to do is take 1 minus root 3i, and I'm going to just change that into polar form. So if we have a look at that, let's see, that's going to be 1 minus root 3, so that's going to be, this is the real number line here, and this is going to be the imaginary number line here, so it's going to be down here somewhere. So we're going to go out 1 and down root 3, and I'm going to find this angle here, we'll call it alpha. So we've got to do two things here. We've got to find alpha, and we've got to find OR here. So to find OR, the distance from the origin is going to be the square root of a squared plus b squared. So that's going to be 1 squared is 1, minus root 3 squared is going to be plus 3, so 3 plus 1 is 4, square root of 4, 2, so our OR is 2. Let's work on this angle here. So alpha then is going to be, actually I probably should call it theta, doesn't really matter, but let's call it alpha for the moment. So alpha is going to be equal to the tan inverse of root 3 over 1. Remember, the tan of alpha is going to be opposite over adjacent, which is root 3 over 1. So alpha then is going to be just tan inverse root 3 over 1. Now, the tan inverse of root 3 over 1, you can get that from your tables. It's going to be 60 degrees. So that's going to be pi over 3. I'm going to use radians here. So alpha actually is pi over 3. However, we're moving in this direction here, if you like. So this is going to be minus pi over 3. It's a negative angle. Remember, the angle has to be between 0 and pi. So 1 minus root 3i is or cos theta. So it's 2 cos minus pi over 3 plus I sine minus pi over 3. So that's our 1 minus root 3i in polar form. But we have to work out, we've got to work out 1 minus root 3i to the power of 9. So let's do that. 1 minus root 3i to the power of 9 is just going to be all of this, 2 cos minus pi over 3 plus I sine minus pi over 3 all to the power of 9. So let's use the Moivre's theorem to work that out. And remember, we have to give our answer in rectangular form, so we're going to have to convert that back to rectangular form once I have that done. Okay, so what we got to do is bring the 9 down. We've got to raise the modulus to 9, so that's going to be to the power of 9. So it's going to be 2 to the power of 9, which is 512. And then what I've got to do is bring the 9 here and here in front of the angle. So let's do that. So it's going to be cos 9 times minus pi over 3 plus I sine 9 times minus pi over 3. Probably don't need those big brackets. That's okay. Let's take them away. 512. And then it's going to be cos of minus, divided 3 into the 9 there, and that gives you 3. So it's going to be 3 pi plus I sine minus 3 pi. So that's our answer in polar form. What we've got to do is convert that into rectangular form now. So let's do that. So it's going to be 512, and now we've got to find the cos of minus 3 pi. So if you think about it, minus 3 pi, it's going to be a minus 2 pi anyway, so minus 2 pi will bring us around to here. And then we've got another pi to go, so that's going to bring us around to here. So really this thing here is just the cos of pi, the cos of 180 degrees. Now the cos of 180 degrees is minus 1, so this just becomes minus 1. And again, you can get that from your tables. Plus the sine, so it's plus I times the sine of minus 3 pi. So the sine of pi, or the sine of minus pi is the same thing, is 0. So that's just going to be 0 in there. Okay, so what do we end up with? We end up with minus 512 plus 0i. Remember, it says give your answer in the form a plus bi, so I would write it out like that. And that's really it. That's really it for part B. Let's move on to part C. Okay, so in part C we have the point minus 2 plus 2i. So that's this point here. Is shown in the Argand diagram. Plot and label the complex number u is equal to 4 cos pi over 6 plus I sine pi over 6 on the diagram as accurately as possible. Okay, so let's do that here. So this is part 1. So we have u, and that's equal to 4 cos pi over 6 plus I sine pi over 6. So we've got to convert this to rectangular form. So it's going to be 4, let's see, cos of pi over 6. Pi over 6 is 30 degrees. The cos of pi over 6, again, it's in your tables. The cos of 30 degrees is root 3 over 2. Plus I sine of pi over 6, the sine of 30 degrees. Sine of 30 degrees is a half. So we'll multiply that by a half, and that's it. Let's see, 2 into 4 is 2, so we end up with 2 root 3 plus 2 into 4 is 2, so it's just 2i. So that's our complex number in rectangular form. So let's just plot that. Now 2 root 3 is 3.46 approximately. So let's we're out to 3.46 is roughly there. And then we got to go up 2i, so it's going to be approximately here. So it says plot and label, and they have that in bold there, so you've got to label it as u, or you can put in the complex number itself there if you want. Okay, so that's really it for part 1. Let's have a look at part 2. So in part 2 it says the complex number is 0, or O rather, is 0 plus 0i. Find the size of the angle WOU. Give your answer in radians. Okay, so let's just plot that. So our O is here, so we're going to look at this angle here and this one up here. Whoops, let me do that again. Okay, so we've got to find this angle here. Let's call it theta, this one here. Now, there's a number of ways of doing this, but what I'm going to do is find this angle and find this angle here, add them and subtract them from pi. So remember, from here to here is pi, or 180 degrees. I'm going to find this angle, which is easy enough to do, and this angle here, which is easy enough to do, then subtract from pi, and that should get me my angle. Let's call it theta. Let's find this angle here. Well, we can see that immediately that it is in fact 45 degrees, or pi over 4. Because we've gone out 2, we've gone up 2, so therefore this angle here must be pi over 4, or 45 degrees. So that one was easy enough to do. Now this one over here then, let's call it alpha. That one can be found easily enough. We know that alpha can just be found by this down along here. We can see is 2. And out along here then we've got 2 root 3. So the tan of alpha here is just 2 over 2 root 3, or just 1 over root 3. So alpha then is just going to be equal to tan inverse of 1 over root 3. We have 2 over 2 root 3. The 2's cancel and we end up with 1 over root 3. So the tan of what gives you 1 over root 3? So it's going to be pi over 6. So that just gives us alpha there is pi over 6, or just 30 degrees. Okay, so we have our two angles. All we got to do now is add those two angles and subtract them from pi. So let's do that. So our two angles are, what were they? Pi over 4, and we've got to add pi over 6. So if you add those, let's see, 12 will go here. That will give us 3, 4 is 12, so it's 3 pi plus 2 pi. And that will give us 5 pi over 12. We've got to look at our angle then. Our angle is, what do they call it here? They call it the angle WOU. So let's do that. So the size of the angle WOU is equal to pi minus 5 pi over 12. Remember, pi is just 12 pi over 12, if you like. 12 pi over 12 is pi, and we got to subtract 5 pi over 12. So our answer then is just 7 pi over 12. And that's it. That's our angle WOU. That's it for this question.